Imagine a 747 is sitting on a conveyor belt, as wide and long as a runway. The conveyor belt is designed to exactly match the speed of the wheels moving in the opposite direction. Can the plane take off? This question led to a lot of confusion, and I want to address this question in this video.
Called World of Engineering that posts interesting engineering facts and questions, and they posted this thing that drove me nuts. Let's read it together. Imagine a 747 is sitting on a conveyor belt as wide and long as a runway. The conveyor belt is designed to exactly match the speed of the wheels moving in the opposite direction. Can the plane take off? Now, I really want you to think about the answer. Take your time.
So actually, I've watched his video, and while I think that most of what he said is true, there are some points where I think that what he said can't be true because of the things given in the task. So I will now present you why I think that the plane won't move at all. In order for us to see if the plane will move or not, I've drawn here the wheel of the plane. The plane will be actually over there, and then it's attached to the wheel via the axis of the wheel. And what we've got here is the belt, and what we've also got here is this coordinate system, and it is actually fixed to a person watching the plane taking off or not taking off. And then we can write down here mark here the contact point, and this contact point this will have velocity VW in relation to this person watching, and it will have velocity VW with this little mark here. This is the velocity it has in relation to the axis of the wheel. So this is in relation to the visitor, and this is in relation to the axis of the wheel. And also the axis of the wheel will have a velocity VA in relation to this person watching, and also the belt will have a velocity VB in relation to this person watching. Now we've got to make an assumption. This is very important because we have to assume that the wheel does not slip over the belt, because else we couldn't solve this problem properly, because it could slip just a little bit, or it could slip all in all, and this would ruin the problem. So now we can write down what the velocity of the wheel in relation to us is. This is so in relation to the visitor, it's the velocity of the axis of the wheel added to the velocity of the wheel in relation to the axis of the wheel. This is just a basic addition of velocities. And now we can also say that the velocity of the wheel must be in relation to us must be the same as the velocity of the belt in relation to us, because else the wheel just would slip on the belt, and if this contact point of the wheel doesn't have the same velocity as the velocity of the belt, then it would just slip. And then we can calculate the velocity of the axis of the wheel. This is just the velocity of the belt right here, and subtracted from that the velocity of the point on the wheel in relation to the axis of the wheel. And now what we've got here is in the whole task, we've got that the velocity of the wheel, this point on the wheel, in relation to its axis. So this is this velocity of this point going that way. That this is actually the same as the velocity of the belt. So what we've got here is that this is the velocity of the belt, and subtracted from that the velocity of the belt. And this, of course, is 0. So we now know that with the given information and this assumption that the wheel does not slip, that the axis of the wheel does indeed not move. And if the axis of the wheel does not move, then the plane that is directly attached to the axis will also not move. But now, how could this be? Because if we look here at the plane, then we see that not the wheels are driven, but actually the turbines of the plane drive the plane forward. So we could ask ourselves, if there is a force produced by these engines that goes that way, then why does the plane not move? Because clearly, if there is a force, then it will accelerate this way. Well, here's the next thing we've got to assume. The next thing, and we could assume that the bearings and the wheels are frictionless, but in this case there won't be any opposing force to this one, and the plane would move. So out of this we can follow the plane will move, will accelerate. But this violates what we just drawn down, because we have calculated that with this assumption that the wheel does not slip, and with the information given in the task that the plane does not move at all. So this is a contradiction to the things we know from the task and from this assumption. So if this velocity is not 0, then we can follow that this isn't true. So if this plane accelerates, and if due to there is no friction, then we can follow from this that the velocity of the wheel isn't the same as the velocity of the belt. But this is a contradiction to the information given in the task, so this can't be. This is a wrong assumption. Just the task itself, we can follow that this isn't true. So I will mark this. And now we could assume that the bearings have friction that depends on the velocity, and this in a way that the faster it goes, the bigger the friction will be. And this is the only assumption that doesn't lead to a contradiction, because else the plane will of course move, and this is a contradiction to the task itself. So this assumption is the only way we can do this. But how will this work? Well, at first this belt will speed up and speed up and speed up, because there's a force that will, in reality, it's a little bit else than in a perfect world, but we will now at first explain. I will now at first explain how this works in reality. So in reality, this plane will move just a tiny bit, and then the belt will react to it so that it doesn't move anymore, and then it would speed up a little bit and it would move another bit, and the belt itself will react to it, and at some point when it moved and moved and moved, it will be so fast that due to this assumption that the bearings have friction, this friction force actually will encounter this whole force of the turbine. So here will be this force. Now we also have to assume that this doesn't break because of this force. Of course, in reality it would break, but we just assume that this is a perfect plane and it doesn't break. So in reality, this plane would move a little bit due to the reaction time of this belt that will accelerate and accelerate and accelerate until the plane does not move. So it will move a little bit. But in the task, we are given that at all time, this belt does match the speed of the wheels. And like we've calculated before, with this information given, the plane can't move. So in this example, the plane won't move at all. It is like if this time in which the belt reacts, it takes to the belt to react is 0, and thus the plane does not move.
I hate these questions with a mild passion, because it's an imaginary situation, and in these situations, in order to arrive at the same answer, it must provide all the proper conditions. But it never does it? It almost feels intentional so that people fight about it and increase the interaction with the post. Which is fine, I guess. At least in scientific cases, it turns people into thinking, which is nice. But I hate it with a mild passion. What are the conditions? Is it happening on the moon with no air, or the air is as thick as honey, like those dreams where you can barely run away from a serial killer following you? Or maybe there are unicorns that can just lift the plane. See, I can only answer based on the conditions I pose on the question. Let's try to solve it. Okay, let's assume we are on Earth and there are no unicorns in our normal atmosphere. But what does it mean the conveyor belt is designed to exactly match the speed of the wheels? Are we talking about the round per minute speed? Because in one turn the wheel can go a couple of meters, but the conveyor belt a couple of kilometers. For simplicity, let's assume it means if the wheel wants to move forward at 1 meter per second, the belt would move backwards 1 meter per second. Now, what causes the plane to fly? It must move with sufficient speed through air to create lift force on the wings, which means the jet engines must be on, pushing the plane forward. Now to simplify, let's turn off the friction between the wheels and the belt. The wheels simply slide over the belt and won't turn because there is no friction. The plane gains speed and eventually flies. Both wheels and the conveyor belt stay at 0 speed. All conditions are met, and that answers the question. Now, the number of replies to my tweets saying if the wheel wants to move forward, the belt moves backward at the same speed, and so the airplane is stationary, is too damn high. An airplane is not like a car that its engine powers the wheels to push the road to move forward. You would be right if that was the case, like me walking on a treadmill going nowhere. But in an airplane, the jet engines push the air back at super high speeds, creating thrust, and it has nothing to do with the wheels.
Well, yeah, of course, as long as the plane can slip over the band, it won't matter what the wheels do because the plane is powered by the jet engines. However, if the plane couldn't slip, then the wheels would still play a very important role, as I explained earlier.
Now, even if there was friction between the wheels and the runway, but the wheels' bearings were frictionless, the plane would still take off. But there would be a problem. If the plane moves forward at a speed v and so the wheels, the belt would have to move backward at the same speed v, which means the wheels have to turn at 2v, which means the belt has to go at 2v, and so the wheels have to go at 3v, and so on. The belt and wheel speed would ramp up, approaching infinity and beyond. Well, if the wheel's bearings are frictionless, nobody cares. The plane speeds up through the air and eventually takes off. And if the wheels don't blow up going that fast, we can say the value of belt and wheel speed are equal at infinity. So we are still good.
Well, no, not really. So, like he said, it's only good at the end when it approaches infinity. But before that, it's not good. The task says that the speed of the wheels always have to match the speed of the belt. So there's no way for it to not match it, and thus, like we followed from that, the plane won't move the whole time. But this is a contradiction, of course, to Newton's law of motion, because with force it will accelerate, and we've got no force against this. So, of course, this is a contradiction, but this just means that the assumption that there is no friction can't be true. So this case, in all, isn't true, and it won't happen because of what is said.
But now, if we turn on the friction all over the place, as soon as the airplane moves forward, the same thing happens as the last case. The belt and wheel speeds would ramp up faster going towards infinity. But now, the wheels' bearings friction creates a growing force as the wheels turn faster, opposing the motion of the plane. At some high wheel speed, this force of friction becomes equal to the jet engine thrust and the plane stops moving forward. The airplane won't take off and the belt and wheels speed match, and this satisfies the question too. Although the belt would have to run at tens of thousands of kilometers for the friction to match the thrust. We have 3 answers now, but I think the real answer could be super stupid. The question states the airplane is sitting on the conveyor belt. Sitting, as in doing nothing. Nowhere it says the jet engines are on. It is like sitting on a regular runway. The airplane doesn't move and the belt and the wheels' speed are the same 0. The answer can be as boring as that. But now we have 4 answers. In 2 of them the plane flies and in 2 of them it doesn't. And we got nowhere.
So to conclude, the second case is just not true. It can't be working. It won't work because of what the whole task said and because of the assumption we made. And so the second case isn't true. The third case is partly true, but I think what he said at the end isn't what he explained is all in all true, because he said that the plane still will move, but we just discussed that the plane won't move at all. So he said it won't fly away, but I go even further. It won't move at all because the reaction time of the belt is instant, and so it can't move. In addition to that, I also think that the plane won't slip. That's because I've calculated that the needed thrust for it to slip is higher than the thrust it will be able to produce. So now I show you how I calculated this, and thus think that the plane will not slip, and thus there's only one option left, that the plane won't move and won't take off. Now I will calculate if it's plausible that the plane does not slip. So will it slip under normal conditions. Its maximum thrust is normally around about 4 times 210 kilonewtons, which is equal to 840 kilonewton. Its weight is approximately 183,500 kilograms. From that, we know that the slip coefficient kappa is equal to 0.9 for the rubber, which is at the wheel. And from that we can calculate that the thrust needed for it to slip, so F slip would be the mass times acceleration times this constant kappa. And with this we get to 183,500 kilograms times 9.81 meters per second squared times 0.9, which is, if I take out a calculator, 1620122 newtons of thrust, which will be needed for it to slip across the ground. Now, the thrust it has is only 840 kilonewton. This is 840,000 newton, and this is smaller than the thrust needed for it to slip under normal conditions. So, plausible that it won't slip. But of course, it will probably break and the rubber will tear apart and things. But we don't talk about this because it should be an ideal plane that can withstand all these forces.